Now we discuss how to calculate the pressure inside a pipeline or a container using a manometer consisted of different columns of fluids. Instead of the step-by-step integration method, we here introduce a person stuck in the pipeline method, which is also called the Tang method. Now we want to detect the pressure of air inside a sealed water tank. One method of this detection is connecting the tank to a manometer of multiple different columns of fluids. In this case, there are mercury, alcohol, and oil columns filled in the manometer. The geometry of each section of different fluids is given by the values of H1, H2, H3, and H4. In order to solve this problem, let's mark each key point with a number. Point 1 is the interface between the atmosphere and the oil section. Point 2 is the interface between the oil section and the alcohol section. Point 3 is the interface between the alcohol section and the mercury section. Point 4 is the interface between the mercury section and the water section. Point 5 is the interface between the inside air and the water section. The pressure at point 5 is just the pressure of the inside air that we want to know. Now imagine you are a person stuck inside the location where we want to measure the pressure, namely, point 5. You want to get out of the place. There are some sections of fluids that exert a net pressure to help you push all the resistance out. We call them friends. There might also be some sections of fluids that exert a net pressure to resist you from escaping. We call them enemies. Our first task is to specify who are the friends and who are the enemies. The atmosphere is exerting a pressure to push you in, so it is an enemy. The oil section, whose net pressure comes from a column of H4, is also exerting a pressure to push you in, so it is another enemy. The alcohol section, whose net pressure comes from a column of H3, is helping you push out, so it is a friend. The mercury section, whose net pressure comes from a column of H2, is helping you push out, so it is also a friend. The water section, whose net pressure comes from a column of H1, is resisting you from getting out, so it is another enemy. Finally, the pressure of the inside air is always helping you pushing out, so it is another friend. At a balanced condition, the pressure from friends and the pressure from enemies should be equal to each other. We count them in one by one, and that should be the pressure of alcohol plus the pressure of mercury plus the pressure of inside air equals to the pressure of atmosphere plus the pressure of oil plus the pressure of water. We further write them into details that we know, namely ρ alcohol GH3 plus ρ mercury GH2 plus P air equals to P atmosphere plus ρ oil GH4 plus ρ water GH1. We further arrange the equation to get the full expression of the pressure of inside air, namely P air equals to P atmosphere plus ρ oil GH4 plus ρ water GH1 minus ρ alcohol GH3 minus ρ mercury GH2. We then plug in the numbers that we measured before. The density of water is 1.010 to the third kilogram per cubic meter. The density of mercury is 13.610 to the third kilogram per cubic meter. The density of alcohol is 0.7510 to the third kilogram per cubic meter. And the density of oil is 0.8510 to the third kilogram per cubic meter. The gravitational acceleration is 9.81 Newton per kilogram. The atmosphere pressure is 101 kilopascal. The length of pressure causing fluid columns are H1 equals to 0.1 meter, H2 equals to 0.2 meter, H3 equals to 0.3 meter and H4 equals to 0.4 meter. This leads to the result of 76.4 kilopascal. Thank you for learning. Feel free to subscribe and like if needed.